Hello, and let's have a look through this sheet. So we've got a nervous system, and I have to name neuron J, T, and Z. So J, T, and Z. Anything else labelled on this diagram? Ah, yes, brilliant, receptor. So that means that I can get neuron Z because I know that it's a sensory neuron. So Zs are sensory. They're always connected to a receptor. Then it's going to go to a relay, and then it's going to go to a motor neuron. And the relay neuron is within D, so D must be the spinal cord. No H in cord. And such E is a muscle. Stimulation of neuron J would cause the muscle to do what? Well, muscles only do two things. They contract and relax. So it's going to be a contraction when you stimulate it. And if the receptor is in the tongue, give three things that it can detect. Now, in terms of our syllabus, we just need to know that it can detect chemicals. However, as we know, if you've ever bitten your own tongue or put it into a hot cup of coffee or something, it can detect temperature, and it can detect touch or pressure, stroke pain. But yeah, you'd normally save those for skin. So if you have to do it in an exam, put chemicals. You can't put taste. Taste is a perception due to chemicals being detected. And the advantage of being part of a reflex arc is that you get a faster response. It must be faster, not just fast. Faster response, therefore less chance of damage to body. Don't put protects you from danger. It doesn't. They just, yeah, when you're in danger, you're less likely to hurt yourself because your reflexes will mean that you'll potentially respond faster. And how does one neuron stimulate another? Well, that's just detail of a synapse. And that's where chemicals diffuse across. Next one, on to the menstrual cycle. So the diagram shows the hormones that are produced in the human menstrual cycle. The numbers show the timing of events. So 1, 2, 3, 4 is on the diagram. Good. I've got a brain labelled as well. See here, brain. I have to label organ X. Well, that's a bit of the brain. That's our pituitary gland. Name hormones 1, 2, and 3. Well, if one is the first one is FSH. Then that causes the ovary to produce estrogen, which then stops the pituitary gland making FSH and causes the pituitary gland to make LH. So that makes sense on the numbers. How do hormones 1 and 3 travel, and why they only have an effect on the ovary? Well, they travel in the blood plasma. So yes, it's in the blood plasma, dissolved in the blood plasma, and the ovary is a target organ. So it has receptors to those hormones. But target organ's enough. That's good. And ovulation occurs at number 4. Why is the egg release delayed until day 14 of the menstrual cycle? So remember, hormone 1 was FSH. That makes the eggs develop, or the follicles to develop. Estrogen then has effect on the pituitary gland, but yeah, estrogen causes the uterus lining to thicken. So this is to give time for the uterus lining to thicken, because it needs to be a fresh, thick lining for the embryo to burrow in and form a placenta. And how are the hormones used as part of the IVF process? Yeah, so FSH, this is basically what does FSH do? So you'd inject a woman with FSH, and that would this makes eggs mature. So you have a dose that's going to give a greater production of eggs, and then you would inject LH like 7 days later or something to causes eggs to ovulate, and that means like they move to the surface of the ovary where they can be surgically collected for IVF. And then lastly, we've got the eye. And I've got here, how does the eye focus on near objects? But I thought if we do a near object, then I'm just going to show you that it's just the opposite for the rest. So if we focus on a near object, this is where the lens needs to be short and round or rounded. So to achieve that, I always think that when I look at a near object, my eyes get tired. So therefore the ciliary muscle, that gets me one mark for knowing it's the ciliary muscle, contracts. And when it contracts as a ring of muscle, the diameter gets smaller. That takes the tension off the suspensory ligaments. So this is when the suspensory ligaments slacken, causing the lens to return to its short and rounded state. The lens is like elastic. You lose that elasticity as you get older, hence why older people need to have glasses for reading. Focusing on a far object, so let's just do the opposite. So yeah, so this is, oops, what that is. Yeah, so the lens needs to be, opposite of short is long, and opposite of rounded is thin. Ciliary muscle relaxes. That means it's going to become a wider circle of muscle. Therefore, this is when tension is applied to suspensory ligaments, which pull on the lens and pull it into a long and thin shape, making it refract the light so that the light rays converge on the retina. But yeah, learn one, and you've automatically got the other. And then same for myopia. Let's go through this. How do we correct myopia? Well, we need to know that like the cause of myopia first of all. Well, I always think this is short-sightedness. It's called short-sightedness, and that means that you can see things close to you, but you can't see things far away or blurry. And it's normally due to a longer eyeball, by like a millimeter. So those two are opposites, aren't they? So I just always think short-sightedness, longer eyeball. I get my opposites in, and therefore the light rays are going to converge, focus or converge, focus before the retina. Because the eyeball's longer, they're focusing before it. So I need to make them focus later. So I want to push out the light rays before they get to the eye. So this is where we can use a concave lens, concave or diverging lens can be used as glasses, or we can laser eye surgery to make cornea flatter. Hang on, I'm nowhere near to writing flatter there, flatter. So if it's flatter, it'll bend the light less, or refract the light less, and therefore that's what we need with a longer eyeball. So let's just do hyperopia. It's not short-sightedness, it's long-sightedness. One of the main causes is a shorter eyeball. Light rays focus. Oh, this is messy, sorry. But focus. If you focus after the retina, So they haven't come to a point at the retina, they're still wide apart, and therefore we use a convex lens, convex stroke converging lens, or laser eye surgery makes cornea rounder. How it does that, I've no idea. I can imagine how it can like evaporate some tissue and make it flatter, but maybe they can just like do some little points of work and it ends up with like a little extra bulge or something. But that's where they get paid lots of money. Right, that's it. 10, 11 minutes, and we've zipped through three big things there and some hard stuff in terms of the eye as well. So all good.